Welcome back to the video series Programming in Python, and this is session 6. In the past sessions, we saw about introduction to Python, flow of control, functions, strings, and lists. In this session, we'll talk about tuples and the rest of the topics in the upcoming sessions. What are tuples? Tuple is an ordered sequence of one or more elements, and a tuple is immutable. It can have elements of different data types, including a tuple. Elements of a tuple can be mutable. We have to see the difference here. A tuple as such is immutable, but one or more elements can be mutable that can be changed within, not as the entire tuple itself. Elements of a tuple are enclosed in round brackets or parentheses. As we saw in strings or lists, the elements are separated by commas. Indices start from 0 and tuple elements are accessed with index numbers. A single element tuple should have a comma at the end, else it is treated as an integer. We have to remember this. If you want to have an element, single element for a tuple value, it should be ended with a comma, otherwise it is treated as an integer. We'll see some examples. I'm defining a tuple here, tpl1, with some numbers, a string, a list item, and a tuple itself. And I'm printing the same tuple. I get all the values or elements of the tuple printed here. Example for accessing tuple elements. If you want to access a particular element or set of elements, I have to define as such. Say for example, I'm print a tuple element with index 0 and print tuple element with index 4. Appropriately, we are getting the values of elements at index positions 0 and 4 here. I want to print an element of a tuple item. Remember we saw it's possible to have a list or a tuple itself as part of a tuple, right? So here I'm printing tuple element 5 and sub element 2. So is index 0, 1, 2, 3, 4 and 5, which is a tuple of numbers. So if I give tuple of print tuple element 5 with sub element 2, I'm going to get 3, which is at the index position 2. Similarly, tpl of minus 1, which starts from the right, so I get the tuple element, which is a tuple internally numbers 1, 2, 3, 4. If you want to have a tuple of single element, we need to end that with a comma, right? So if I give without comma, what happens? If I give with comma, what happens? I have a TPL2 tuple with 10, no comma, TPL3 with 10, I'm printing both. The first one is printed as an integer, second one is printing as a tuple itself. You have to remember the difference when we are dealing with tuples. Now let's see some differences between tuples and lists. I have a table here with lists on the left side and tuples on the right side. Lists are mutable, tuples are immutable. The whole list as such is mutable, which means the entire list can be reassigned with new values, whereas the tuple is immutable, meaning the tuple cannot be reassigned with new values. However, elements of a tuple can be changed. They are mutable. Iterations in a list are very slow, but in the case of tuples, iterations are faster because there is same reason, the mutability and immutability plays a role here. And lists consume more memory, tuples consume lesser than lists. Insert or delete of items are easier because they are mutable and the Python system allows that. But in the case of tuples, it's not as easy as lists. Tuple data type to be used to access elements. List has several built-in functions, whereas tuples have very limited built-in functions. We see those tuples built-in functions in further slides, but comparatively, lists have a lot of built-in functions provided by Python. And because of mutability, unexpected errors in lists are more likely, whereas tuples, it's very limited or not possible in many cases. Next, we'll see tuple operations. Tuple has concatenation, repetition, membership, and slicing operations, as we saw in list. Concatenation, joining two or more tuples with a plus operator. repetition, repeating a tuple n times with a star operator, membership, checking for an element to be part of a tuple or not with in, or an element to be not part of a tuple or not with a not in clause, and slicing gets one or more elements of a tuple with a given range of index values. It's the same as a list as well, so we'll see how it works. Some examples. I have two tuples, one with some numbers and a string, another with a list and a tuple element. When I say TPL1 plus operator TPL2, this is what I get as an output. And if you have another tuple with another string element, remember if you have a single element tuple, I need to end that with comma. So I have a comma here, and TPL1 plus 2 plus 3, I have a new tuple with the last string being added here. Since the elements of a tuple are mutable, I'm able to add car as a third tuple here. Otherwise, I will not be able to reassign values for TPL1 or 2 or 3 here. You have to remember that. The next operation is repetition. As we saw, using the star operator, repeat a particular tuple a number of times. Here I'm printing TPL3 three times, so I'm going to get values appropriately. And a combination of operators, as we saw as an example in list as well. Next operation is membership. We have the same example, same tuple here with numbers, string, list, and tuple elements. And I'm going to look for the string ABC in the tuple. Since ABC is part of the tuple or element of the tuple, I'm going to get true. The next one, I'm going to look for Toyota as an element. We have to be very careful here. Though we see Toyota as a text or string here, it's not an element by itself. It's a sub-element of the element list. That is Toyota and Innova combined together forming a list. That's an element of your tuple here, not as a separate element by itself. So we'll be getting false here. And I'm going to check for Maruti not in this tuple. Since Maruti is not part of the tuple, I'm going to get true. And I'm going to check if 4 is not part of the tuple. Since 4 is an element of this tuple, I should be getting false. The next operation is slicing. Slicing is in the same example as we saw earlier. We have to give a range of index numbers to get a slice of the tuple. So I'm giving tuple of index 1 through 4. If I give 1 through 4, I'm going to get elements having index 1 through 3. So I'm going to get 4, 5.6 and ABC as the output here. And I can have start, stop and step conditions for my tuple operation, slicing operation. Here I'm giving step as 2. So I'm going to get this as output. Similarly, the negative values reading from right to left. Traversing tuples. Like in lists, we can traverse through a tuple with a for and a while loops. Here we have an example of tuple, and for each element of tuple, print that element. I'm getting each element printed sequentially. Next is using a while loop. I have the same tuple here. As long as there is an element in the tuple, print the element. Look at the length of the tuple, and till you reach that length, keep printing the elements. That's the logic we have here, and each of this element is getting printed one by one sequentially. Tuple methods and built-in functions. Remember, in the comparison between lists and tuples, we saw that lists have a number of or huge number of built-in functions, whereas tuples have a very few. Here is the list: length, min, max, sum. A tuple is a function itself, sorted, index, and count. Very few of them, and the usage is also kind of limited, and there are restrictions around data types being used within the tuple as elements. Tuple assignments. This feature allows assignment of values from a tuple to variables of another tuple, meaning the tuple on the left side with variables can be assigned with values of tuple on the right side of the assignment statement respectively. there is a main condition or just one condition. The number of variables and values on either side of the tuple should be equal. Otherwise, there will be a mismatch and Python will throw an error. Here is an example. I have two variables num1 and num2 as part of a tuple on the left side, assignment with equal to symbol, and I have two values on the right side. And these values can be assigned directly or with an operation. Here I have a couple of arithmetic operations 10 plus 5 and 5 into 5. These are done first and then assigned to the variables num1 and num2. If I print number 1 and number 2, I get the values appropriately. Another way of achieving assignment is to create a tuple variable and assign the values with the tuple elements on the right side, and then assign the tuple variable to values of the tuple on the left side. As we see here, have s underscore details as the variable for this particular tuple values or elements, and then I am assigning the variable to name, age, and course. When I print name, age, and course, I get the values or elements of the tuple printed together. Next, we will see nested tuples. When a tuple becomes an element of another tuple, it's called nested tuple, just like in list. To access the element of a nested tuple, two indices are needed. First is the index of the nested tuple of the main parent tuple, and then the child or sub element of the tuple. We have the same example, and if I try to access this index 0, I'm getting the first element 2, index 4, the fifth element, Toyota and Innova as the list itself. If I want to access an item of the list element, I'll give the index values accordingly. For example, here, tuple 4 and 1, I'm going to get the first indexed list item, that is second element, that's Innova here. Similarly, if I want to access one of the elements of the tuple element within the main tuple TPL1, I'll go with this. Now let's see some sample programs on how to handle tuples. This is the first sample. The same thing we saw in the slide. While there is an element in the particular tuple, print all the elements. Let's see how it works. Here is the output. I have all the elements getting printed in the IDLE. Next, we will see a sample for creating a tuple with user input and finding the maximum and minimum number from that tuple. I have stored as a py file. Let's run it and see how it works. The program is going to ask the user for number of elements as well as the elements. So let's say 5 elements, and I give some random numbers. They all have to be numbered because I'm receiving integers. So elements of the tuple as I entered, and it's showing me the maximum number and the minimum number as per our program. A quick look at the program again. So the user is asked for number of elements until the user enters number. So it has to be a number. If the user enters blank or some other character, it's going to throw an error. And for that number of elements, receive the elements from the user and then print the numbers or elements as is and the maximum and minimum numbers. Next is a sample as an extension of the previous sample. Receive the numbers and sort them using the sorted function of tuples. It's a built-in function. We have to remember that the sorted function brings out output in a list format, list of characters, list format, not a tuple format. So let's run this and see how it works. I'm going through the same steps as before. Let's say I have 6 numbers to be sorted, and I'm giving some random numbers here. Here is the list as entered. The maximum is 876, minimum 0, and the sorted list is 0 to in ascending order in a list format. We have to remember this is in a list format. Coming back to the presentation, let's have a quick recap of what tuples are. Tuple is a sequence of elements enclosed within round brackets and separated by a comma. Indexing is used to access elements. First element index should be 0, and negative indexing is also possible, just like strings and lists. Python tuples are immutable, whereas the elements of tuples can be mutable. We have to remember that. The operations include concatenation, repetition, membership, and slicing. Each element of a tuple can be accessed with a for or a while loop, as we did for strings and lists. There are very few built-in functions for tuple as opposed to strings and lists. Tuple within a tuple is called a nested tuple. Now here are some hands-on work that you can try out. I've tried to kind of make them equivalent to list programs so that you can see the differences, or you can compare between lists and tuples. First one, write a program to find the largest element of a tuple. We will have, or we would have had a similar one for lists as well. Write a program to find the number of times an element appears in a tuple. Write a program to compare two tuples and print the elements that are present in both. Write a program to delete duplicate elements from a tuple. Write a program to receive a tuple from user, reverse the elements and print. And try out a few by yourself as usual. See, some of them will be tricky as opposed to less, because you would have a lot of built-in functions for less, whereas we have a very few. So anywhere there is no built-in function, you would have to find a way to program using statements. Please remember that. See you in the next session on dictionaries.